Hello, this lecture is on Unit 4, Standard 3, and this is talking about what we've been talking about already about extrema, local and absolute minimum and maximum. But this time, and for the next lecture, we're going to apply it to some real-world examples. In this particular example, we're going to be looking at that absolute min and max, but applied to position, velocity, acceleration, and speed. So something that we already touched upon before, something you know for a fact you will get on the AP exam, and something that I feel if you got this on the AP exam, you should be very comfortable and very happy that you're getting these questions because they're not very difficult. So this particular example says a particle travels along the x-axis with the position function x squared equals to t to the third power minus 5t squared plus 8t plus 1, and the interval is from 0 to 3. So first of all, it says, is the particle traveling left to right at t equals 3? Well, if I want to know if it's traveling left to right, I'm going to have to take the derivative to get the velocity function. And when I plug in 3, if I get a positive number, it's going to the right. If I get a negative number, it's going to the left. So the very first thing I'm going to do is I'm going to take, you can see my function in the top right corner, I'm going to take the derivative. My velocity at t is 3t squared minus 10t plus 8. And again, it says, what is it at 3? So I'm going to do is plug in 3 and see if I get a positive or negative number. This is something very simple that you can do in your head. So I get 3 squared, which is 9, times 3 is 27, minus 30, plus 8. If I do my math correctly, that is 5. 5, and again, there's no units in this one. Remember, all of these position, velocity, acceleration problems should have units. So I don't have any units, I can't put any units. But since I have a positive number, I have a positive 5, and let's just say for this example, I'm going to call this meters per second, I know it's going to the right because it's positive. And because I'm running out of space, I'll put right because positive. But the question B says, when is the particle furthest to the right? So this is a particle based on its function. It's going back and forth, left and right, left and right. I want to know, when is it furthest to the right? So if you remember, if I want to find the furthest or the maximum of anything, I take the derivative and set it equal to 0 first. I already took my derivative, so I'm going to plug in 0. Like so. And then I need to find out what the critical numbers are. I set it equal to 0. So what I'm going to do next, let me just see if I did this correct. Yeah. What I'm going to do now is I'm going to factor this and try to find out what my critical numbers are. Well, I know that this has to be 3t, and this has to be t. I got to think of some numbers that if I plug it in, I get, if I add them, I get a negative, or if I multiply them, I get an 8, and I have a negative 10t here on the inside. So let's just try, hold on real quick. Let's try a minus 4 and a plus 2. So I put a minus 4 here and a plus 2 here. If I multiply them, oh, this doesn't work. Let's try a minus 2 and a minus 4. Because if I multiply those, I get a positive 8, and if I multiply it out, I'm going to get a minus 10 on the inside as well. So it's been factored out. I know that for this to equal 0, this has to equal 0, or this has to equal 0, which means the time has to equal 2, or the time has to equal, in this particular case, 4/3 seconds. So what I found is that where the particles furthest to the right has to occur at 4/3 or 2. Remember from the last lecture that it's not only at these 2 points where it could be the furthest right, but it could also be the endpoints. If I look at the original problem, they told me that the endpoints of this interval are 0 to 3. So the possible scenarios are 4/3, 2, 0, or 3. Okay. If I want to know where it's furthest to the right, remember I have to plug this into the original function. So if I zoom out, I need to take all of these and put them back into the original function to see where is this furthest to the right. So what I'm going to do again is I'm going to plug this into a calculator, or if you want, you could also use wolframalpha.com if you want to. So I'm just going to really quick go over to the website. I'm going to type in t to the third power minus 5t squared plus 8t plus 1 when t equals, and the first one we have is 4/3. So I'm going to do when t equals 4/3. So I'll put into this calculator, and it tells me that I get 5.14. So what I'm going to do is I'm going to put this into, I'm going to bring up my, here you go. Bring up my notes again, and at 4/3 I get 5.14, or 5.15 if I round up. Okay, so this is what I get at 4/3. Now let's try this at time equals 2. So again, the great thing about using Wolfram Alpha, I could just erase that and plug in 2. When 2 is plugged in, I'll let the calculator calculate it, and I get 5. So back to my thing here, I get 5. If I plug in 0, it should be very simple for you. If I plug in 0, you can look at the original function. If I plug in 0, they all become 0 except for that 1. And if I plug in 3, again, I'll go back to my calculator. I'll plug in 3. Let's see what it tells me. And I get 7. So here are all my critical points and the endpoints. I'm plugging all the numbers, and this is what I get. 5.15, 5, 1, and 7. So this tells me that at time equals 3, that's when I hit my furthest right, and that value, what is its position then, is 7. Normally you write that out, but again, for sake of time, I'm just showing you how it looks like. You would literally write out the maximum position, or the furthest it goes right is 7, and that occurs at time equals 3. Okay. Next question says, when's the particle furthest left? Well, you know, we already found all the values, the critical numbers, and I also put in the endpoints. I already calculated all of them already. So instead of doing any work, I can find out when is the particle furthest to the left. And for you, you could see that the furthest to the left, or the smallest number, is this one over here. So it's, when is the particle furthest left? T equals 0, and its position is 1. Okay, that's how you do that one. Now, this is where it gets a little bit tricky. It says, what time does a particle reach its minimum velocity? And what is its minimum velocity? So this is very similar to the last problem we did, but instead of looking for the maximum and minimum position, like furthest left and furthest right, I'm looking for minimum maximum velocity. So basically I'm going to do the exact same steps, but instead of taking just one derivative, I'm going to take another derivative to find out the minimum and maximum velocity. So if you remember, if I scroll up, my velocity function is this. I'm going to take a derivative of it, which is 6t minus 10. And then if you remember, because I want to find out where its minimum maximum are, I set this equal to 0. I'm going to factor out a 2. And I find out that my value, or the critical number, has to be 5/3. So the only critical number I have is 5/3. When I'm testing though, I have 3 values I'm going to test. I have my critical number, but I also have my endpoints. Remember, endpoints are 0 and 3. If you remember, I have to plug these numbers into the original function. But since I'm looking for velocity, minimum and maximum velocity, I plug these into the velocity function. In this particular case, the velocity is my original function. So again, I'm going to put this into my calculator. I'm going to change up my formula. So I'm going to go back to my calculator. Instead, this should be 3t squared minus 10t minus 10t minus 10t plus 8. So let's try all 3 numbers. The first number, remember my critical number was 5/3. So let's say when t equals 5/3, put in the calculator and let's see what value we get. I get 5, so back on my notes, I'm going to say when I plug this in, I get a velocity of 5. Okay. When I plug in 0, again, this should be easy. When I plug in 0, going back to my velocity equation, if I plug in 0, I'm going to get 8. And then 3, I'll put this into my calculator. Let me go back to my calculator. I'll calculate when t equals 3. And again, if you want to use this, you can do this on your iPad as well. And I get 21. So now when I look at this problem, It says when does it reach minimum velocity? The smallest number I have is 5, and that occurs at 5/3 seconds. The next question, E, says when does it reach a maximum velocity? You should know that its maximum occurs at t equals 3, and the velocity is 21. And again, there's no units, but I'm just going to make one up for now, just so you get used to using units for everything. Okay. Now, I'll put one here too. So that's how you find minimum and maximum velocity. And the last one we're going to do today, it says when does it reach maximum and minimum acceleration? We're doing the exact same thing, just do it one more derivative further. So there's a of t. A prime of t, or the derivative of velocity, is going to be 6. Okay. Remember when you find your critical numbers, you set this equal to 0. There is no critical numbers in this problem because 6 will never equal 0. So the only numbers I can test are my endpoints, which are time equals 0 and time equals 3. So that tells me I hit max and min acceleration at the endpoints, whether it's 0 or 3. Again, I'm going to plug this into quote-unquote the original function. In this case, since I'm finding max acceleration, I'm going to put this into the acceleration function, which, if I use a different color, my acceleration function was right here. These ones are small enough where I could do this in my head. If I plug in 0, I get negative 10 acceleration, meters per second squared. If I plug in 3, I get negative 4 acceleration, which is, sorry, if I plug in 3, I get 8. My fault. Plug in 3, 6 times 3 is 18. 18 minus 10 is 8 meters per second squared. So now the question is, what time does it reach maximum acceleration? Well, it hits max acceleration at time equals 3, and that acceleration is 8 meters per second. What's the minimum acceleration? My minimum acceleration is at time equals 0, and it is negative 10 meters per second squared. So this should be a bit of a review, and we're not going to do anything about speed. Don't worry about that one. So it's very simple, same process that we've been doing and practicing, but we're now applying it to these real world applications or word problems. So I hope you understand it. Hope you're understanding without me there. If you have any questions, feel free to message me or email me. I want to make sure you guys understand how to do this stuff, even though I'm not there. So thank you for watching, and have a good day.